make an oxide. You know what's great about this? I'm seeing everyone in green. So the other thing, besides burning incredibly hot, it puts out a huge amount of light. It's actually very efficient at converting this heat into light. And it turns out a lot of the light is going to come out as ultraviolet. So, interesting thing to say to people, but don't look directly at the light, look away. Kind of keep it in peripheral vision. You ready? So, metal, go into the light. So, hey Stephanie, want to turn the light back on? So if you notice, this is a white metal now, and you're, like I was saying before, that this guy is like tasting metal before, and I want to become a regular guy. So this stuff is magnesium oxide.
No.
Pretty good. And if you get magnesium oxide into water, like on my tongue, it becomes magnesium hydroxide, which is an antacid and a laxative. So I become a regular guy. I'm done with my show. See you later. Gotta go.
You'll be here all week.
I'll be here all week. Yeah. So, oh, by the way, you notice this stuff is really white. See that white stuff? Very white. This white stuff is the oxide. So remember this: magnesium oxide is very white, and it combines with the oxygen in the air. It also combines with the nitrogen in the air. And if I blew on it, I couldn't put it out with my breath because it combines with the carbon dioxide in my breath too. It really wants to burn. As Ron was saying, magnesium has these 2 extra electrons hanging on the edge. And if it could, not if it could, it really wants to get rid of those 2 extra electrons. And one way to get rid of those extra electrons is to give it to oxygen. And when it does that, it combines with the oxygen. But over here on the table, like I was saying before, is I have carbon dioxide. It is not oxygen, it is carbon dioxide. It is CO2. And what I'm going to do is I'm going to take magnesium metal, and I'm going to put magnesium metal inside. Ooh, yeah. A little more? More? More. Yeah. There you go. A little more. So I'm going to put some magnesium metal in between 2 blocks of carbon dioxide. I'm going to throw a couple more pieces of magnesium ribbon in there. I'm going to put...
Spice it up, Eric.
What's that?
Spice it up.
Spice it up? I'm going to put a magnesium fuse in there. There you go. That should do it. What do you think?
Yeah.
So this thing wants to burn so much and grab onto the oxygen, it'll pull the oxygen out of the carbon dioxide. So if I pull the oxygen off of carbon dioxide, what should I have left? Carbon. By the way, I will show you, this is pure carbon over here. Just to kind of give you a heads up. Child-proof safety cap there. This is, let me see if I can get some on here. This black stuff right here, carbon. Okay, got it? Carbon black. So the amazing thing about this reaction is that you can see everything that goes in and everything that comes out. And the equation is, for all of those people that are into chemical equations, how many people here are into chemical equations? Yeah, outstanding. The equation is going to be, we're going to put magnesium in, we're going to combine it with carbon dioxide, and we're going to have on the other side, we're going to have magnesium oxide, which, what color is the magnesium oxide? White. And we're going to have carbon. What color is carbon? Black. Black. Okay. Put this over there. Okay. So, what I am going to do is I am going to put this out of the way. Grab this over here. So when I get this thing going, I'm going to slam this thing shut with another layer of carbon dioxide so that we'll not have access to oxygen. Let's see what happens. Come on. Here we go. You guys ready?
Yes.
Are you sure? Here it goes. Did I remind you not to look at it? No, it's okay. You can look at it. Anybody have a good book we can read by? So the reaction has stopped, and now it's just cooling down in between the slabs of dry ice. So we're gonna have to wait for it to cool. And when it's done cooling, I'm gonna pop it open, and we'll see what's inside of it. Hey, I take requests. What do you want to hear?
Another question, is the UV blocked by the dry ice?
The UV is blocked by the dry ice once it gets going. Yeah. That's when I was picking it open. I have a green UV filter on my welding goggles over there. But once this is on, you guys are good to go. There's a lot in there.
Yeah.
How'd that happen?
By request. You want to know about the Teacher Institute?
Yes.
So we train teachers from all over the world. We have trainings every summer. We bring teachers in. We bring in dozens and dozens of teachers. We bring them through a 3-week institute, and we also provide 1-week institutes, and we have workshops virtually every single weekend. This weekend, I'm doing carbon networks. And if you know a district that wants to have us out there, especially an exotic district far away, that'll provide our salary and food and transportation, I'm willing to go there too.
Another question on Coursera.
Oh, that's right. We have a course. You guys know about Coursera? Yeah. We have a Coursera course starting up in about a week and a half or so. But by the way, I'll remind you, we got a lot of this stuff inside of here. Yeah, so we're on Coursera. We're doing a course on light and color. That'll be starting in about a week and a half. So you can join 1,000 other people that are signed up, or 2,000 are already signed up. Do you have a question too?
Yeah, so right now it's still glowing.
Yeah.
Because it's just because it's hot, or is it because it's actually still reacting chemically?
It's might be reacting a little bit, but mostly it's because it's just cooling off. It is incredibly hot. This stuff burns at over 3,000 degrees Celsius. Whoa. So there's a chunk of material in there that was burning incredibly hot. And once this thing starts cooling off, it's going to cool off pretty quickly.
It burns underwater, right?
It'll burn underwater. It'll burn sand. We have a fire extinguisher here for safety.
Not a regular fire.
And it's not a regular fire extinguisher, but I will tell you that magnesium fires are incredibly hard to put out. You can't put it out with carbon dioxide. Okay, you ready?
Yep.
Okay, here we go. Drum roll. Oh, wait a second. So what should we see inside of there? White stuff, and what else? So we had metal in there. It looked very metallic before, and now we have see the white stuff? And inside of that, we got black stuff. So the black is the carbon that got pulled out of dry ice, and the white is the magnesium oxide, which is a laxative and an antacid. If you want to, in a minute or so, I'll have you come up. You can touch this stuff. Don't touch the dry ice. I'll put this over here. And this will be cooling down. This is not too bad right now. And we are lucky, Stephanie, we didn't burn it all the way through the dry ice.